Hi everyone, welcome to Teach Meet WA Reach. This is episode 5, part 2, and this episode is all about design and technologies and digital technologies curriculum in a high school setting. And we've got some high school teachers with us tonight and some interstate presenters as well. So we'll just go through and introduce ourselves before we get started, and we'll pass to our interstate presenters. So Roland, would you like to go first and introduce yourself?
Thank you. My name is Roland. I'm a STEM leader at Mater Christi College, science educator, technology educator. Hell, I just like making and breaking stuff and figuring out how it works. Next year I'll be a lecturer in STEM education at Monash University, but we'll hear a bit more about the things I've been also up to this year.
Thanks, Roland. We'll go over to Amanda. Would you like to introduce yourself?
Hi everyone, I'm Amanda Rablin. I'm an e-learning coordinator in Brisbane, Queensland, and I also co-host a Google Hangout show with Roland as well, called the ACCELN, so ACCE Learning Network, and we're here together-ish because we've been working on a project together that's incorporating STEM, design tech and digital tech at some level, and it's a lot of fun.
Thanks, Amanda. We'll go over to Megan. Megan does present for us regularly, but I'll let you introduce yourself as well, Megan, for those people who are tuning in for the first time.
My name's Megan, and my current job, I've just stopped teaching as a science teacher, but I'm working for the Science Centre SciTech in Perth, and I'm with the professional learning team, so I help upskill teachers in any of the STEM fields. So lately we've been doing lots of robotics and coding and the technologies curriculum. So yeah.
Thanks, Megan. We'll go over to Adam as well, who's our co-host for Teach Meet WA Reach. But Adam, would you like to just introduce yourself quickly, because you'll be presenting tonight too?
Cheers. Thanks, Hannah. My name's Adam Brooks. I'm an IT teacher at Colby Catholic College in Rockingham. I co-host TMWA Reach regularly with Hannah as well. Thank you.
Thanks, Adam. And we're also hopefully going to be joined by Petra, but she's having some Wi-Fi issues at the moment. So hopefully she can pop in and we'll get her to introduce herself a little bit later. So I'll just screen share and we'll have a look at what we're doing tonight. We'll flick over. Here we go. All right, so this is episode 5.2. And those are the Twitter handles if you are willing to tweet as we go along to those people. This will be available on our YouTube channel if you need to tune out halfway through or if you would like to catch up. If you've got questions throughout, you can hashtag TeachMeetWAReach on Twitter or plug through Facebook as well, and we'll answer those at the end. And tonight's objectives are to feel connected no matter where you are situated, and to discover resources to assist in the digital technologies and design and technologies curriculum, and that's in a high school setting. So tonight we're going to start with Amanda and Roland, who are doing a bit of a team presentation this evening. We'll then go to Megan, who's talking about Hummingbird robotics. If Petra can join us, she's going to be discussing Adobe Fuse and Maya character animation. And then Adam is going to be talking about Unity game engine and C# programming. So we'll flick over to Amanda and Roland to start their presentation. And you guys can get started when you're ready. Who am I flicking to first, Roland or Amanda?
Definitely Roland first. He is the inspiration of the whole project.
Amanda's alphabetical.
All right, we'll pass to you, Roland.
It started off with a big, hairy, audacious goal. I had a cup of coffee with a lovely chap called Russell Jenkins. We've done some projects in the past with Vic Roads, and the first goal we had was to build an autonomous vehicle. I did that with a wonderful team of students at Keysborough College. What was interesting with that was that when we had a chance to tour the Vic Roads Operations Centre after having made the model and think about how this kind of fit in the big picture, one thing that really important with the students was that if we're going to have robots perhaps redefining how cities are kind of working, then we have to realize that they're actually part of something much bigger. the mind map that we constructed after doing this operating tour showed that the city wasn't just a system of vehicles which gradually became smarter. It was actually part of a much wider system of things that were kind of networked together. There was a lot of sensing that was going on. There was a lot of automation, calculating, modeling to improve and make life a lot simpler. We call this a smart city. We don't hold a monopoly on the term, but that became the kind of prototype for what we wanted to model, which was a smart city, a place where robot cars can independently make their way through traffic lights, buildings, and pedestrians. In a sense, you have autonomous vehicles communicating with intelligent infrastructure and these randomly non-programmable things called pedestrians kind of weaving their way through. And I'm glad Amanda's giggling there, because we started off klutzing with some different, we even tried building our own model car, didn't we, with the Hummingbird kits, Amanda?
Yeah, that's right. And I was involved in it since the I guess the pilot phase, when it was just looking at an autonomous car, and we used the Hummingbird as part of that adventure and some make-do kits, and we tried to retrofit a Hummingbird onto a make-do car cardboard experience, and that was kind of fun. And then after the smart city idea evolved, we ended up using the MBot robot for our autonomous vehicle, our car. I think Roland might even have one.
Here we are. This is an MBot.
And we found they were a lot easier and more able to suit our needs than the Hummingbird was. But our random crazy pedestrian was actually the Sphero robot. And so we created a city and a track, and it was I guess a collaborative project rather than a competition kind of one. So there were schools all around Australia that had teams who were investigating how do we build a smart city and how do we get these MBots and Spheros to act as though they're actually participants in the city. And our group also added some Lego EV3 robots, and we used that as a train. There were talk of drones, and we built some really interesting kind of features for our city, and including using our Hummingbird as a bit of a boom gate. And even though we didn't get it fully operational, it was pretty cool watching the group of students that I had, which were year 7 and 8, come up with ideas to create both a city, mostly out of cardboards and boxes and all kinds of random equipment. It was lots of craft fun, and also programming of these different elements.
It was a lot of fun to try and see all these different things trying to integrate and work together, and getting the kids to look at the kind of activities that might make for interesting problems that we can solve with technology. I liked the collaboration that was kind of happening, and it was a really good use of technology, making the kids see that they were contributing to something much bigger. In a way, the ITS group that we were then working with, and ITS is Intelligent Traffic Systems, was in a process of actually coordinating efforts by different countries to produce a city for the future, to have the collaboration for the intelligent infrastructure we might want to have, protocols that we might have for communicating and solving those problems, and being able to share some of the strategies you might do that. We presented the work that we did at a World Congress on the 10th to the 14th of October at the Melbourne Convention Exhibition Centre. There were over 10,000 people who participated in the conference, and we had around 2,500 school children who came through. And Amanda, you were part of that, even though you were in Brisbane. We knocked their socks off by doing a live hangout with your classroom.
Yeah, that was pretty fun. The video gods played nicely for us that day, and we gave the people who were witnessing the presentation a tour of our robot city and some of our programs kind of in action as well, which was pretty fun.
Yeah, and we also had a school, Jennifer Ashbury, involved some of the rural schools in Victoria, and I know we had Mark Webber from WA. He came down, and he managed to also, in the makerspace that we created, had the students quite excited, turning carrots into a piano. But he also made a lot of references to that you can do this too. It wasn't something you had to wait for some obscure bit of technology. The robotics are off the shelf. The inspiration, that's something that teachers have to help provide the students to engage with it. We also had other schools involved, Amanda. I know in the early stage we had the school, the Australian Science and Maths School in Adelaide. My old school, Keysborough College, also put together a display. But how about we actually have a look, because they had a journalist crew come down, to perhaps showcase what it is the kids did. And in this video, you'll see also some of the buildings that we made.
I'll just pop that on now for you, Roland.
Why, thank you.
Just delegates from across the globe getting involved here at the ITS Congress in Melbourne.
But also local school children who've been taking part in the Smart City competition. Their challenge to build a model city with intelligent vehicles that integrate with intelligent infrastructure. I'm joined now by team leader Roland Guesthausen. Roland, thanks for joining us. Can you just tell us a bit more about the competition and what the kids have come up with?
Well, it was a Vic Roads sponsored ITS-inspired conference. We were challenged to try and model, as our big hero audacious goal, a smart city. And that meant we had to have smart vehicles, smart infrastructure, and a lot of communicating. And for the students, they've done the bits and pieces, but integrating this together into a city system was a challenge. And going and visit the Vic Roads traffic operation room gave us some inspiration, and look at what we built.
So, Cara, can you just tell us a bit about what you've come up with?
We've built a smart city, which we have robots going around using optical sensing technology to sense the colour, so it follows the black road and has a crash prevention thing in front, so it senses not to crash. And we built this so we could base a safer and better city.
Dale, this looks pretty impressive. Can you tell us all about your city?
Well, basically, us at Keysborough College, we've been focusing on the technology side of a smart city, in which we've been creating infrastructure which is run by Arduino Unos and is run by Arduino coding. And from that, we've then allowed the vehicles to communicate with the infrastructure, creating a smart city and what has effectively been the future in STEM and the way that we're going to start living our lives.
Well, there you have it, some teenagers with some very smart ideas about our cities of the future.
I'll pass it back to you, Roland.
Thank you. It's messy because there's these bits that are all over the place, and that doesn't sit sometimes comfortable with teachers that would like to do levers in week 3. We even threw into the mix a drone. And the idea of this was that you had to program it using a particular software to get from A to B in the city. The buildings you might have noticed there were something that we're inspired with at the Belgrave Lantern Festival. I happened to work with one of the artists, and she showed me how to layer the, how to describe it, a laminate of baking paper and PVA glue, very craft-oriented thing. And we had a chance to also put some LED lights into it and build that up. There were different ways you could approach it. You could look at it as just a simple design construction problem, or you could look at it as a coding problem, or you could look at it as an integrated system problem. Ultimately, what inspired the students was a chance to showcase the way that they might solve some of the problems that make the world a better and safer place to be.
Wow, thanks, Roland and Amanda. I'm getting like goosebumps because I am a primary school teacher, and all I can see is just interdisciplinary learning, hands-on experiences for the kids. And I just think it's such an outstanding example of where I hope that students will head into high school. So thank you so much. What an amazing example.
Thanks for letting us join you.
Okay, so we're moving on now, and our next presenter is Megan, and she's presenting on Hummingbird, which is quite appropriate because you did mention Hummingbird in your presentation. So it's all connecting. Lovely. I'll pass over to Megan.
Yeah, so we have a few Hummingbird kits now at SciTech, and I guess some people I talked to have heard of it before and some haven't, so I thought I'd run through what it is. Because it is a bit of an investment, it can be expensive, and what it's good for in the technologies curriculum, so you can make a decision about whether it would suit your situation or not. So, share this. Now, I've taken most of these images from the Hummingbird website itself, Can't take credit for that. This is what the Hummingbird board looks like. And to me, I describe it as a beginner's Arduino. So it's on the back, you can use it as you would use a regular Arduino, or you can use it on the front, which is a little bit bigger and has the bright colors, which is using it as a Hummingbird. So that's the regular Arduino Uno there on the right. So you can compare, it is a bit bigger, and it does look different on the front. And I find it a bit user-friendly for people who've never ever touched Arduino before. So when you're using an Arduino, you do use electronic components like you can see down the bottom there. But when you use the Hummingbird, you can either use these or the bits that come with the Hummingbird. So you'll notice that they have much longer leads or wires on their legs. And it's all color-coded. And the way that they work is, I'll just flip back. You hold down a button on the colored plastic bits on the Hummingbird here, and you shove the wire in and you let go of the button, and it's clamped in place, so no soldering required. And it's really easy for the students or anyone to undo that in between projects, or if you need to reuse it between classes. Now with the Arduino, you don't necessarily need to solder, but you will need to have a breadboard like this one shown here with all the little holes to place your components in. So you need to learn how to use a breadboard as well, which isn't complicated, but it's just another thing. So for me to pick up and use straight away, a Hummingbird is a little bit easier if you're a bit hesitant about getting started in this area. Now, the other thing I like about Hummingbird is they've got multiple options for programming it. So the first one is called the CMU Create Lab, which was made by a university in the US, and it's symbol-based programming. And then you can move on to one that's becoming quite popular and well-known. And I should point out, these are all freely available on the Hummingbird website, so you don't pay for the software. You can use Scratch or Snap, which is pretty much the same thing, to program the Hummingbird as well. I think this is a really good lead-on from the primary school, because a lot of students are coming through now having experience with Scratch, so you can start them off with Scratch and using Hummingbird and then move on to the next ones. Now, with Year 9 and 10 and even Year 7 and 8, in the curriculum, students need to be able to program using text-based stuff, but it can just be, it doesn't have to be an actual language. It can just be a language like the text you see in the Scratch blocks there. It's not until Year 11 and 12 where it specifically says you need to start using a real coding language. Now, as we move on through all the different types of software you can use with Hummingbird, ArduBlock is a really, really good one, because it's a bit of a bridge between the symbol-based or the click and drag, like Scratch, to the actual typing code. So it shows you on the right the symbol-based stuff, and then on the left it shows you what it would be in the Arduino coding environment. And this is a good bridge. And then once you feel comfortable just using the Arduino environment by itself, you can do that just by itself. And a lot of the code already exists, so it's a matter of copying and pasting bits together. You're not expected to write this from scratch. But then you can also, with the Hummingbird, use it on the Arduino side and do coding or programming with languages like Java, Python, and processing. So it does cover that range. Like I was talking about the dashes last week, you can just tailor the software to your students to meet where they're at with the same piece of equipment. This is from the Hummingbird website, an example of a project. That Smart City one looked amazing. This is a bit simpler, I think, but they've used the Hummingbird to make the dog move. So it has, they've used the distance sensor in its nose. So when you come close, its eyes light up. Oh no, sorry, the distance sensor's on the top of its forehead there. When you come close, its eyes light up and it waves its hands at you to say hello. So that's just one example. They've got lots of examples and resources on their website to get you started, but it's a really good tool to use to mix the coding and programming from the digital technologies with the design process from the design and technology side of things, and do a project that combines both of them together. And this can be attached to anything that you want to use, like Amanda was saying, they used it with the Lego We-Dos as well. So it's you don't need Lego. You can just use cardboard and crafty bits and pieces, or you can use whatever you want. There is potential to make a robot out of it, but I haven't seen it used for that often, because normally if you want to use a robot, something like an M-Bot would be a bit of a better choice. But yeah, so it's really creative, it's really open and fun, and there's lots of different software options. There's heaps of support and help on their website. So even though it is expensive and a bit of an investment for the gear, if you have the money, it's definitely worthwhile, and ours are being used all the time. It's really hard to get a hold of them, actually, because everyone wants to use them. I'm just going to stop my screen share if I get. There we go. So yeah, that's Hummingbird Robotics. Yeah, I hope that was enough to inspire you to go check out the website and get started.
Thank you, Megan. I loved all your examples of how the different programs you could use with it. And I think that's a really nice starting place for high school teachers. So thank you.
No worries.
I'm just hearing feedback that I didn't screen share that video that Roland and Amanda had for their presentation. So what we'll do is we'll pop it through Twitter. Sorry about that. That's my not screen sharing properly. And we'll pop that up for people later on, because it was a fantastic video. So next we were going to switch to Petra. Petra, are you with us at the moment? No, I think she's not there. So what we might do is just go straight to Adam. Adam, are you all ready to present?
Yeah, I'm good to go here.
Perfect. If Petra can join us, we'll pop her in at the end.
No worries at all. Thanks, Hannah. Just excuse me, I've got kiddlywinks in the background, not wanting to go to bed. So I'm here to talk to you today about the Unity game engine and using that with the C# programming language. People might be asking, what is a game engine and how does it work? The easiest way of thinking about it I guess in another context is just like we can have an engine in a car that provides all the functionality for that car to work. You can build different games with that particular engine. So it has all the parts there ready to go for games, and you just program the user interface and the gameplay into the game using that game engine. So Unity is great. It is free for educational institutions. So once you set that up, all the students can access it. It is available on Mac as well as Windows. If you've got Mac or Windows at your school, then that's suitable. So I'm just going to share my screen. So I'm going to share my entire screen. Hopefully this works. All right, so this is the Unity game engine. So when we open up a project, I'll just open up this one for an example. Hopefully it's going to work. So it looks a bit daunting, but the best way I've found for students, and I must admit I haven't tried this with classes just yet, only with students from my dev club, but I'm preparing for this for next year's digital technologies classroom. Now, the Unity game engine comes with two programming languages, so C# and JavaScript. Now, for those of you who haven't done much programming before, JavaScript is typically used for web development, and it's probably an easier language to use in terms of it's not as strict on the rule sets, whereas C# is an object-oriented programming language. So it is used, I guess, more to do with formal programming because it allows you to do that object orientation. It may be easier to start with JavaScript, but what I found with the Unity game engine is that it doesn't actually all the programming was originally done in C# and JavaScript is just a new addition. So a lot of the tutorials are in C#. So I've decided to use C# for next year, and we'll see how that goes. As you can see, you've got a number of different, menu items and things like that. And I said it can be daunting for students, but typically you've got a camera that's set up, and we can change the position and rotation and of that camera so it looks in different directions. We can also add in different materials. So materials would be, for example, if we wanted to give a grass a certain texture, or give particular attributes to a surface. We can also import 3D models, and hopefully if Petra can talk, she'll talk about Maya, and Maya is a 3D modeling program which we can add models to. There's also this concept of a prefab. So in this particular tutorial that I was doing, there is a pickup item, and if you want to generate multiple items, we can add them all with the same attribute. So if you change one, you can make changes to all of them. So if you imagine the game Lemmings, for example, and there's 100 different lemmings, we can give all of those lemmings the same look and feel, the same attributes, and just generate multiple ones. The other thing, I guess, as well, is that we can script these things as well. So I'm going to give you an example of what this looks like. Just wait for it to open. So it will open up in your development environment of choice. So Unity comes with this mono develop tool, and we can see some C# language. So as I mentioned before, Unity is a game engine, so it comes with certain things, certain coding already done for you. So for example, with input, if we want to get input from the arrows keys, we can use this particular function. And so rather than having to deal directly with if this button is pressed, then do this, we can actually use a function that's already been written for us. And we can take in the value that it gets from left and right and from up and down, place that into a vector, and we can add a force to a particular object. So in this case, I had a ball that was kind of rolling around on a table, and when I pressed left and right, the ball would roll to the left or the right. If I pressed up and down, the ball would roll up and down. So that's all good and well, but if the students don't know the C# programming language, then it's going to be very difficult for them to come into a game engine and start using it. So what my plans are is to do this in conjunction with a program called SoloLearn. So SoloLearn is free. There are a number of other tools like Code Academy, which are great, but our students have iPads at our school. So the SoloLearn can be used as an app on the iPad as well. And as you can see, there's a number of different tutorials on here as well. So I'm just going to click on the C# tutorial, show you what this looks like. So it comes in different modules, and it works through like a quiz. So you can look at these basic concepts, and so it gives you some information there and provides a quiz using that information. So you can see, got it correct. And that goes through from the basics all the way through to object orientation as well. So really quite a useful tool, and it's useful as well because Code Academy is a bit of a pain when it comes to using on the iPad. So I found this tool quite useful for them to get access to that information. So obviously presenting a game engine in 5 minutes isn't possible to try and show you all of that. But what I can do is if you go to the Unity website, there are a number of different tutorials that are available. So if you go to unity3d.com and click on the Learn, there's a number of different tutorials there. And as I mentioned before, the tutorials are mainly in C#, so that's why I picked that. So we have 2D games and 3D games there. This one and this one are virtually the same tutorial, and they're really good as a starting tutorial. This one for dimensions and this one for 3 dimensions. What I found was with 7s and 8s, because there is you need to have an understanding of vectors. 2-dimensional vectors are probably an easier way to get started if they haven't had the concept of 3D vectors in science. But once again, that might be something you want to challenge the boundaries with. So that's Unity and C#. If you've got any questions, feel free to post them up on Twitter. I'm going to be preparing a whole heap of resources for next year for this, and I'm going to make them readily available. So if it's something you're interested in trying with your students, then feel free to get in contact with me, and I can provide those resources too. So thank you very much.
Thanks, Adam. Those are some great resources that you shared, and I'm sure people can use them. So thank you. It looks like Petra has now joined us. Hopefully we can switch over to Petra. Are you there, Petra? I've been messaging her and it looks like she's in. She's just having a bit of difficulty at the moment. Maybe not.
She's just trying at the moment.
Okay.
Give her a few more seconds. Are you there, Petra?
Having trouble with her home Wi-Fi, I think, at the moment.
Someone needs to send her the NBN stat.
Yeah. All right. Maybe we can talk about next episodes.
That sounds good.
And yeah.
So,
want me to present?
Oh, it's up to you. I suppose this is the last one for this year for Teach Meet WA Reach. So we might pop a poll out to see what people are interested in for next year. We can plug that through Twitter. And people can vote on the episode for 2017. Adam, did you have any ideas of what kinds of things?
Yeah, I guess what we wanted to know from the audience, I guess, is where would you like us to head in 2017? So if you use the TMWA Reach hashtag on Twitter and give us some suggestions about things that you'd like to see presented on here, this is all for you. So let us know what you would like to see. Once we've got some ideas, we'll put them together in a poll, and early next year we will present that on Twitter and through the Facebook group, and then you can vote for it then.
Perfect. Thanks, Adam. So that's it for this evening. Thank you so much to especially our interstate presenters who've stayed up quite late to present with us this evening. So Roland and Amanda, big claps to you. Thank you. And thank you, Megan and Adam, for presenting as well. And thanks, Petra, for trying. Hopefully we can maybe record. Oh, she's there. Petra?
I'm back. Can you hear me?
You're lagging a little bit, Petra.
Hello.
That's better.
A little bit. I'm wondering if, fingers crossed, I've got a couple of tabs open at the same time. So I'm going to try now and share my screen.
Perfect.
So
okay.
First of all, I just wanted to give a little bit I guess it's a good basis and quite an easy way to actually start looking at 3D. Now, we have some software from Fuse. Oops. Where is my Fuse model gone? Okay.
Petra, I think we've lost you again. We might just have to leave it there for this evening, Petra, and maybe you could screencast your recording and pop it up on the TeachMeet YouTube page. Thank you everyone for presenting this evening again, and hopefully our audience will do the hashtag TeachMeetWIReach for things that they're interested in for next year, and we will see you next time. Thank you. Bye.